So this is a tricky one. There's two key things. So we've got to go y equals, let's get that over. So y equals, it's going to be k, and we go x minus on the top, and then on the bottom, we also go x minus and x minus. Okay, but here's what we have to remember. This one has a couple of really tricky points. First off, this 2, this is x-intercepts on the top and vertical asymptotes on the bottom. But this x-intercept point right here is a bounce point. See how it bounces right there? So that always, whenever something bounces, that means second power. So this is going to be second power on the top. And we're going to plug in the 2 right there because it's right at 2, that it bounces. That's second power. And what it comes from, I want to help you remember this, and there's a lot to keep straight on the exam. You remember x squared, that's an x squared function. It bounces right there. So, right, so second power is where things bounce. Okay. Now, another way you can think of bounce is it's both up, or, you know, you could also, that's also a bounce, both down. Okay. Now, let's go to the vertical asymptotes. On the vertical asymptotes, I want you to look at this one first, the -1. Do you see how one side goes up of the vertical and the other side it goes down? That's normal. That's normal. That means he's a first power. Whereas this guy, look at him. They're both going down. That means he's another bounce. He's a bounce second power. He's a bounce asymptote. He's got to be a second power. So the 3 is a second power. The -1 asymptote is just regular first power. That's the extra trick on this one. Do you see what just happened there? So let me slow that down and look at that carefully with you. So this is really weird when they go on the same side of an asymptote line. The normal thing is to go up on one side, down on the other of a vertical dotted line. That's normal. So this guy's a normal, just first power. I'm not going to even write a first power. For the -1, he's just a normal vertical asymptote. But the 3 is a very special vertical asymptote because they're both going down. Same thing if they both went up. Either way, it's bouncing, so to speak. Bouncing means, you know, they go on the same side. So just like this dot here is a bouncing x-intercept, meaning they both go on the same side of him, this is a bouncing vertical asymptote. They both go on the same side of him. So he's got to be second power. That's super tricky. See, we don't normally have that. Look back. Well, I won't bother you too much to look all around, but that's what we gotta pay attention to. Okay, so then what becomes of it? So this becomes y equals k x minus 2 squared over x minus this is going to be minus a -1, so +1 times x minus 3 squared. So look at those two square powers. Those are really important. One of the x-intercepts is squared because he's a bounce, and one of the vertical asymptotes is squared because he has the effect of a bounce, meaning that the graph goes on the same side of him on both sides. Okay, so that's pretty tricky. And now we plug in the y-intercept, which is 0 minus 0.5. So that's the x and the y. Plug in 0 for x everywhere, minus 0.5 for y. Let's see what we get. So then we get negative 0.5 equals k times 0 minus 2 squared over 0 plus 1 and 0 minus 3 squared. And that's negative 0.5 equals k. On the bottom, that's minus 2 squared. On the top, it's 1 times minus 3 squared. Keep going. negative 0.5. That's k times 4 over 1 times 9, notice. And so that's negative 0.5. Yeah, let me back that up a little bit. So that's negative 0.5 equals k times 4 over 9. How do you solve for k? You multiply by the reciprocal, the upside down, 9 over 4, cross cancel, and k equals, just use your calculator now, take 9 divided by 4 times negative 0.5. I think you're going to get negative 4.5. Let me double check on my calculator. And what? 9 over 4. Oh no, I messed up. So it is negative 1.125. There it is. Yeah. Yeah, that's it. Negative 1. So there we go. We got K, a lot of work. So what's the event? Let's bring that K back up here. Bring it up, and away here. So we got our K, negative 1.125. So that means the final answer to this problem is y equals negative 1.125 x minus 2 squared over x plus 1 x minus 3 squared. So that's the trick on this one. You've got to square the top x-intercept because he's a bounce point. So that's the moral of this story. He's a bounce point, and this vertical asymptote is a bouncer because they're both on the same side that he is on. That's what makes this really tricky on that one. So those, whenever an x-intercept is a bounce point or a vertical asymptote is a bounce, meaning they're on the same side, that's second power. So there we go on that.